An open box with a square base is to have a volume of 14 feet cubed. And we are to find the box dimensions that will minimize the amount of material used. In other words, we're supposed to minimize the surface area. And the surface area we're going to represent by A. Now, generally, the surface area will be the sum of the areas of the 5 sides of the open box. Notice the box does not have a top. We have been told that the variable to be used for the side of the base is x. So let's let the width be x and the length be x. We've also been told that the volume is equal to 14 feet cubed, but in general for a rectangular box, the volume would be width times length times height. So in our case, substituting the 14 for the volume, we'd have x squared times h, which we can solve for h to give us 14 divided by x squared for the height. So now we've got the length, width, and height all written in terms of x. So the area will be the area of the base, which is x squared, plus 4 sides, which all have the area x times h. Or, in this case, x times 14 over x squared. When we simplify, we get x squared plus 56 over x. So we have that the surface area is a function of the length of side of the base, which is called x. This is a rational function. X cannot be 0. It contains 2 branches and does not cross the line x equals 0, which would be the y-axis. And so let's take a look at this function on the graphing calculator. So we'll go to y equals and put in x squared plus 56 divided by x. That's going to be our function. We're going to adjust the window. And we're going to have it go from -5 to 5 for x min and x max. Y min we're going to let be -40. Y max we're going to let be 80. And Y scale can be 10. So now when we graph, we will see the 2 branches of this rational function, and we are interested in only what's in quadrant 1, where both the variable x and a are positive, because we need a positive side and a positive surface area. So we can see that there is a relative minimum in quadrant 1. And on the TI-84, to get that, I go second table, which gives me calc. Press 3 for minimum. and it asks me for a left bound. I use the right arrow to come fairly close, but to the left side of the minimum value. I press enter. Now it asks me for a right bound. So I stay close, but this time go to the right side of the minimum value. That's the lowest value. Hit enter again. It's asking for a guess. I can let the calculator do the work by pressing enter again. And it says, correct to 3 decimal places, that the x value where the minimum surface area occurs has a value of 3.037 feet. And so now I can go back to the other screen and write down that the x dimension that minimizes the surface area to 3 decimal places is 3.037 feet. So it's going to be 3.037 by 3.037 because the base is square times the height, which is 14 over x squared, or 14 over 3.037 squared. And correct to 3 decimal places, this is 1.518 feet. And so each side of the base will be 3.037 feet, and the height of the rectangular open box will be 1.518 feet. This time we had to go to the calculator. It was not a quadratic function where we can just find the vertex.